This lesson introduces the last method we're going to look at for solving quadratic equations. We've talked about factoring, which only really works when things actually factor. We've talked about incomplete quadratics, which is a special way to solve when we have quadratics missing a b term. And now we're going to see a way that solves any quadratic using a formula. So looking here, the quadratic formula is derived or comes from the process of completing the square to solve the general quadratic equation ax squared plus bx plus c equals 0. It works for solving any quadratic that is in this form as long as the a value is not equal to 0. So basically this means that you have an x squared term, right? The quadratic formula will not work if it's not an x squared equation. Now, note, completing the square is a method used in 9th grade, but we are not going to go over it this year. We're focusing on the other types of methods. So this is the quadratic formula right here. The hardest part of using the quadratic formula is the simplification step at the end, which you will practice in the next text box below. So basically, we plug the values of a, b, and c in, we simplify it, and our answers at the end will look like one of these four. So there's 4 different things that I can think of that are the ways that you might have to simplify. The first way is if you get something like this, you're always checking this square root to see if you can simplify it first. If you can't simplify the square root, you're done. So this one, square root of 11, that does not simplify. So this expression is already simplified. Yeah, I have a million arrows there, so I'm just going to erase them. So this first one, if you can't simplify the square root, it's already simplified. The next one, when I check this 50, I can simplify it. Now, if you look at all these and just take a step back, it really feels like you should be able to simplify the 3 and the 6, right? You cannot, because both of the terms have to be divided by 6. Right now they can't be, and you cannot go inside the radical to simplify, or to simplify the fraction, because you have to bring numbers out. So that's where we're headed. 50 breaks up into 25 and 2. So this is going to be 3 plus or minus, the square root of 25 is 5, so 5 square roots of 2 over 6. If you need to go back to the last lesson, that's where I spent a little more time breaking down simplifying radicals. Now looking at this, both of these numbers have to have a common factor with 6 in order to simplify this, and that's not true. The 5 and the 6 have no common factors. So moving on to our next one, now we have a 72. 72 is kind of a tricky one because it has 4 and 9 that go into it, but 4 times 9 is 36. That's the biggest perfect square. So I want to break it up into 36 and 2. So when I simplify this one, I get 3 plus or minus 6 radical 2 over 6. Looking at those 3 numbers, they all have a common factor of 3, so I can simplify this. And I do that by dividing each of those 3 by the common factor of 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. If you're wondering, I don't have to simplify the square root of 2 because this is one term, right? There's no addition between there, so I can just simplify the number in front, and then this is a 2. So I don't have a ton of room, but I'm going to write it down here. So this gives me 1 plus or minus 2 radical 2 over 2. My last one, an interesting situation comes up. This is actually just 5. So if I do this one, I get 3 plus or minus 5, right? I don't have to break it up. Square root of 25 is just 5. Now, if you get to here where all the radicals are gone, you actually have to break these 2 up to simplify. So I'm going to break it up into the 2 answers. I have 3 minus 5 over 6, right? I'm just using this negative sign, or 3 plus 5 over 6. So this gives me negative 2 over 6, which is negative 1/3. This gives me 8 over 6, which is 4/3. So those are the 2 answers here. On all the other ones, breaking it up wouldn't matter because I can't really do anything with it, whereas when it's all numbers, I can get them down to pretty simple fractions. So now we're going to look at actually using the quadratic formula to solve these 2 problems. So the first thing I need to do, and we won't do this every single time, but I'm going to identify the values of a, b, and c. So my a value, it's 1x squared. My b value is 12. and my C value is 18. Then I'm going to take those numbers. This time I'm going to copy down the quadratic formula so we can really see where those numbers are going. So I'm just copying my formula from top of the page, and then we're going to plug the numbers in. So this negative b is going to be negative 12 because b is 12. And then here I have b squared, so 12 squared minus 4 times 1 times 18. And then that's all over, so I plugged in the a, b's, and c's on the top, all over 2a, so that's just 2 times 1. So once I get that far, my recommended method for finishing the simplification is to type this directly in your calculator. So you're going to type that 12 squared minus 4 times 1 times 18 directly in your calculator to avoid any small errors. So that's going to give you, for that part, when you typed it in, so the blue is what you typed in, 72. So now this should look just like what we had up top in terms of picking how to simplify it. So we already did 72, so I'm going to do that kind of quickly. So this is square root of 36 times the square root of 2 over 2, negative 12 plus or minus 6 radical 2 over 2. So when I look at my three numbers, they have a common factor of 2. So this is going to become a negative 6, this is going to become a 3, and that just becomes a 1. Since we're dividing by 1, I actually don't have to write my denominator anymore, so these answers are negative 6 plus or minus 3 radical 2. I know I've kind of gone over into that other problem. I just want to make sure everyone realizes for these answers, which are here, right, they actually represent two answers. So if I split them up, my one answer is negative 6 minus 3 radical 2, and my other answer is negative 6 plus 3 radical 2. If I was going to go and type this in my calculator, it would give me a decimal. I'm not going to write the decimal because it doesn't ask me to round it, but be aware these are still actual values. If we graph the quadratic, it crosses the axis somewhere at some sort of decimal value. So I'm going to have to erase some of this so I can do the next question. Let me just get that off here. As I'm erasing, just looking at my next quadratic, 5x squared minus 3x minus 1, when the b value is negative, so in this case that's negative 3, I have to be a little bit more careful about how I plug into the quadratic formula. So my a value here is 5, my b value is negative 3, and my c value is negative 1. This is a negative 3 here, by the way. So I'm not going to rewrite the formula this time, I'm just going to put the numbers in. So first off, my formula says negative b, so I need to write negative negative 3, plus or minus the square root of negative 3 squared minus 4 times 5, 4ac, times negative 1. Now looking at this parentheses around the negative b value, or the b value is really important. You can't put the squared inside the parentheses, it has to be just that number inside the parentheses, because I want negative 3 squared to equal positive 9, because that's what it is, and if I don't type it that way into my calculator, it will not evaluate it to a positive 9. So this whole thing is over 2 times 5, 2a. Simplifying, I get positive 3. When I type in this expression, that's going to give me a 29, right? I'm typing it exactly as I see it in my calculator, and then over 10. So my two answers here are 3 minus radical 29 over 10, and 3 plus radical 29 over 10. It is, once again, fine to leave it in this form, right? The x equals 3 plus or minus radical 29 over 10, but just be aware those are two separate answers with actual values. So a follow-up question, how can you tell from your solutions to the two quadratic equations above that the original equation, so I'm just going to add this, that the original, that says original, I promise, equations are not factorable. So I'm talking about my original equations. How can I tell those aren't factorable? And the answer is, when I get answers like this, answers with square roots, which are irrational numbers, if they have those square roots left that don't simplify, there's no way that I would have get that if I had factored. So my answer is the solutions are irrational. And what that means is contain square roots.